So let's go over.
Are you actually recording?
I need to get rid of this square root.
You're not recording.
So let me square both sides.
You're not recording?
I
You're
am
not
recording.
recording this part?
See, that's why I don't record this class. I am recording. Now, doing so gets rid of my radical. X minus 1 equals, here, can be rewritten as x minus 7 times x minus 7. Then I need to distribute. So x times x is x squared. X times negative 7, negative 7x. Negative 7x times x is negative 7x. And negative 7 times negative 7 is a plus 49. Now what we'll probably want to do is combine like terms. So x minus 1 equals x squared minus 14x plus 49. Looks like most of you got this far, so very good. Notice I have a quadratic. I need to set my quadratic equal to 0. So let me move everything over. Negative x and a plus 1. That's going to give me 0 equals x squared minus 15x plus 50. Now to solve this, I should probably graph it like I've done here. Graphing it, I see my solutions are 10 and 5. So 5 and 10. Now we're not done yet, are we? We need to check for our extraneous solutions. So if I plug in 5, I get 5 minus 1, which is 4. Square root of 4 is 2. So the left side is 2. Plug in for x, I get 5 minus 7, which is negative 2, which does not equal 2. So 5 does not work. That is an extraneous solution.
Did you hide Waldo to me?
Not yet.
Oh, he's right there.
He is right there. So let's try 10. If I plug in 10, I get 10 minus 1, which is 9. Square root of 9, the left side is 3. If I plug it into here, 10 minus 7 is 3. 3 does equal 3. So yes, Emily, thank you. X does equal 10. I had to throw away 5, but 10 is okay. So there's how we solve one radical. When we introduce two radicals, the theory is still the same. How do you get rid of a radical? Square both sides. Well, either way, we're going to square both sides. What happens here is the idiom, I kill two birds with one stone. So that gets rid of this radical on the left. I'm left with 3x plus 4. Also gets rid of the radical on the right, 5x minus 6. And now I'm left with the linear equation that I can solve for x. So move x to one side of the equal sign. Subtract my 3x here. Gives me 4 equals 2x plus minus 6. Add 6 to both sides. So isolate your variable. I get 10 equals 2x. And last but not least, the opposite of multiplying by 2 is to divide by 2. And you get x equals 5. Or does it? Well, let's plug it in. 5 times 3 is 15. Plus 4 is 19. I have the square root of 19 here. 5 times 5 is 25. Minus 6 is 19. I have the square root of 19 right here. So the square root of 19 equals the square root of 19. Therefore, x does in fact equal 5. So two square roots. Make sure you have them on opposite sides so that when you square them, they cancel each other out, right?
No, we just finished writing.
Okay. So as I look in this next problem, what would you want to do first?
Send the 7 to this side?
Yes, I need to send one of these radicals to the other side. To be honest, I probably wouldn't send a 7. I would probably send a negative. So I would want to add square root of 5x plus 2. So I'm trying to just really keep everything as positive as possible. That gives me a radical on the left, square root of 7x, and a radical on the right, 5x plus 2. Now it's set up to where if I square both sides, I kill 2 birds, 1 stone. And I get 7x equals 5x plus 2. Subtract my 5x. I get 2x equals 2.
X equals 1.
Divide by 2, x equals 1. Or does it?
Check it.
Yes, let's check it. 7 times 1 is 7, so I have the square root of 7. 5 times 1 is 5, plus 2 is 7, so I have the square root of 7, minus the square root of 7. Does that equal 0?
Yes.
Yep. So 1 works. There we go. X does in fact equal 1. So when you're working with 2 square roots, first thing is to make sure that you have 1 on either side of the equal sign. Are we with me so far?
Yes.
Because now it's about, I wouldn't say it gets hard, but now it gets complicated. Now, before yesterday I said we need to make sure that we get the radical by itself. Well, if I move this 5 over, then it's just attached to this radical. So there's no way around isolating a radical. You're just going to stick with one of these with a number attached to it, which is fine, but it just requires more work. So the steps are the same. I'm going to square both sides. Square, square. Now, unfortunately, what happens was this side is okay. That radical disappears. But I need to rewrite this as the square root of x plus 5 times the square root of x plus 5. So you see what's going to happen now. Now I need to start multiplying my radicals. Thankfully, when we were in the R section, the first 2 months of school, we actually did this. So hopefully you can recall a little bit of it. So this left side is x plus 5, and now I need to distribute my right. So what do you get when you multiply square root of x times the square root of x?
X squared.
Well, no, you get the square root of x squared.
Oh, yeah.
And what is the square root of x squared? It's just x. Because we've been seeing that if I square my square root, they cancel. So square root of x times square root of x is just an x. You just get what's inside the radical. And then now, square root of x times 5 is 5 square roots of x. Multiply this one, 5 times square root of x is 5 square roots of x. And then last but not least, 5 times 5 is 25. So I got rid of one of my radicals. I still have another I need to deal with. But let's first combine alike terms, group this together, so that we can decide what to do next. So x plus 5 equals x. I'll move this 25 over, and I'm going to add my radicals together. 5 square roots of x plus 5 square roots of x gives me 10 square roots of x. Okay, so now we're kind of back to yesterday. I have one radical. What should I do first before I square?
Isolate.
Isolate. So I'm going to move this x over, which happens to cancel on both sides, lucky us, and this 25 over. That gives me negative 10 equals 10 square roots of x. What would you want to do next?
Divide by 10.
Very good. So I have this 10 attached to my x. Let me go ahead and get rid of it by dividing it, or not rid of it, but move it over. Now I have negative 1 equals the square root of x.
You square it.
So now I can square it on both sides. And I'm left with 1 equals x. Or does it?
Check.
Let's plug it in. 1 for x. gives me 1 plus 15 is 16. Square root of 16, my left side is 4. Square root of 1 is 1. Square root is 1. 1 plus 5 is 6. Does 4 equal 6?
No.
Oh no. 1 failed. So what does that mean my solution is?
No solution.
No solution. Unfortunately, all that worked for a no solution. Some of you might have seen it already, because notice right here, I have the square root of a number equals a negative number. Can that happen? No. You'll never get a negative number out of square root, unless you're talking about imaginary. So it failed actually at this part right here. Actually kind of failed here too, because you'll never get a negative out of there. So no value for x will make that satisfied. No solution. All right. So again, your goal yesterday was to isolate the radical. Unfortunately, with double radicals, there's no way you can do it if you have a number attached to it. So you're just going to have to be left with distributing. So let's see that one more time. Something's wrong with this problem before I should start squaring. Yes, got to move on the radical zone. We want a radical on both sides. So add square root of x plus 1. This is going to be a true welcome to college algebra problem. So it equals the square root of x plus 1 plus 1.
Then what was the last one?
Well.
Okay.
Now that I have a radical on either side, what should I do? Only way to get rid of a radical is to square it.
Mr. Clark sounds like Dora.
What'd you say to me? I sound like what? A doormat? Adore it? A dork. What did you say? I don't even know y'all still use the word dork.
I said Dora.
Dora? Who?
Yeah,
Dora
you
who?
know how like when she's like.
Dora? Like the Explorer girl? Dora. Dora.
Only because you were like.
Only because I was like,
Never mind.
I want to get people on camera seeing how you believe me. Got evidence. I'm gonna get you canceled.
You can't cancel me.
Oh. All right. So that gets
So
rid of the radical
stupid.
on the left. I'm left with 2x plus 3. Put this radical on the right.
I hate math.
To help me distribute, I need to rewrite it as square root of x plus 1 plus 1 times square root of x plus 1 plus 1.
I don't want to write on it,
Whoa.
so I'm gonna wait till you.
There you go. Now let's distribute. So what do you get when you distribute square root of x plus 1 times square root of x plus 1?
X.
Very good. X plus 1. That radical just disappears and goes away. What do I get when I multiply square root of x plus 1 times 1? Well, let's just say square root of x plus 1. And what do I get when I multiply 1 times square root of x plus 1? I get another 1, so I'm going to change this to a 2 square roots of x plus 1.
Weird.
And then 1 times 1 is a 1. So does everybody follow me from right here?
No, but yes.
Where I got this from this.
How'd you get 2x plus 1?
I have 1 and then 2. So square root of x plus 1 times 1 is 1. Square root of x plus 1 times 1 is 2 of those. So I just kind of skipped a step and went ahead and combined the like terms.
Oh, okay.
Just to save space.
The first part, when you multiply both of the, when the square, it just cancels out.
Yeah, so these will become square root of x plus 1 squared, which
Oh, so
cancels.
cancel out.
Yeah, it'll cancel out. Again, sorry, I'm trying to save space here. So I'm kind of cheating a little bit. Now, well, I still have another radical, so I need to isolate it, right? So let me move everything over. So subtract an x on both sides. I'm going to subtract a 1 here, and then another one. that's going to give me
X plus 2.
x plus, not 2, 1 equals 2 square roots of x plus 1. Because if I add these together, I get 2, and I'm subtracting 2.
Oh.
So I moved over 2 negative 1s.
9 is 6.
That gets me here. Now we have a decision to make. I saw a teacher over lunch, and he was showing his students, well, isolate the radical, right? Divide by 2. And I'm like, you don't want to work with fractions. So let's just keep this number here, and let me show you what happens when I square this radical with the number there. So we have a radical. What's that? Yeah, I told you.
You're teaching wrong.
Square both sides. This gives me x plus 1
Responded.
times x plus 1 equals, now what happens here, what's 2 squared? 4, and when I square my radical, I get x plus 1. So that number here is still being multiplied to this set here. I just have to square it 4, and this radical, which is squared, so the radical goes away, turns into parentheses. So I still need to multiply this number to whatever this group of numbers is here, but now the radical's gone and it's in parentheses. So see how this works. If you square with the coefficient in front of your radical, square that number, that coefficient, and then turn the radical into parentheses.
You just start from the beginning.
Which part? So let me distribute all this, but good news is my radicals are gone, right? So now x times x, which is x squared, x times 1, which is just x, 1 times x, which is x, and 1 times 1, which is
no solution.
1.
I
1.
think it is. I just tried it.
It's not going to be a no solution.
It's gonna be the 1.
And now, let's
It's gonna be
distribute
1.
here, 4 times x, which is 4x, and 4 times 1, which is 4.
Okay, now you have to combine everything.
Yeah, now we have a quadratic. Now we got to move everything over. Right?
What is this? Like, what is this?
4x minus 4.
It's not even hard. It's just long.
Exactly. That gives me my quadratic of x squared minus 2x minus 3 equals 0. X squared minus 2x minus 3 equals 0. Finally, we got here. Something y'all know how to do, which requires just graphing. So I'll look at my graph. What are my solutions?
3 and
Negative 1 and 3. So x equals negative 1 and 3.
Wow.
And even though you did all this work, you're still not done because you need to
Check.
Check.
Stupid word.
2 times negative 1 is negative
Graph
2.
it.
Plus 3 is 1. Square root of 1 is 1. Negative 1 minus 1 is 0. Square root of 0 is 0. 1 minus 0, is that 1?
I don't even know how to check it because you have to.
Yeah, you got to plug it in. It is. So negative 1 works. Next number.
My finger's strong.
2 times 3 is 6. Plus 3 is 9. Square root of 9 is 3. 3 plus 1 is 4. Square root of 4 is 2. 3 minus 2 is 1. So hey,
Ready?
both numbers work. X equals
Oh,
negative
maybe
1
we-
and 3. Who got that? This one is already set to where I have a radical on either
It's gonna
side.
cut me out.
And now we're good to go to square both sides.
He gave us more than 5 minutes.
So that gets rid of this radical. So I have a 3. Sorry. I have a 3 minus x equals, now this is square root of x plus 7, oops, times plus 2, times square root of x plus 7 plus 2. Now when I multiply
6 periods.
square root of x plus 7 times square root of x plus 7, I get just an x plus 7. Multiply here.
I need to go. Okay.
Square root of x plus 7 times 2 is 2 square
my
roots of
wallet.
x plus 7. Same thing when I multiply here. I get another 2 square roots of x plus 7.
Because I'm staying.
And then 2 times 2 is 4.
So I can come back.
Let's clean this up a bit and combine our like terms. 3 minus x equals x plus 11 plus 4 square roots of x plus 7. Who got this far? Okay, y'all get this far?
Yes.
All right.
You know we did.
Let's isolate our radical. So we'll get it by itself. So subtract x on both sides. Subtract 11 on both sides.
Excuse me.
That's going to give me negative 2x minus 8 equals 4 times the square root of x plus 7. I would not advise dividing by 4. You're going to be stuck with fractions. But if this was a 2, that would be a good strategy, right? Otherwise, let's just go ahead and, once again, square both sides. Now, this needs to be rewritten as negative 2x minus 8 times negative 2x minus 8. And that equals a 16 times x plus 7. Where did I get the 16 from? Well, that's 4 squared. And this radical disappears and turns into parentheses. Now here's where some are having some issues, distributing here. So let's look at that. What is negative 2x times negative 2x? That is a positive 4x squared. Negative 2x times a negative 8. That is a plus 16x.
Oh my god.
Negative 8 times negative 2x is a plus 16x. And then negative 8 times negative 8 is a plus
But can't you just skip all that?
64. That equals, let's distribute this, 16x plus, somebody, what's 16 times 7?
48.
Do you even know?
48?
112.
112. This should be an x. So now let me subtract, move everything to one side so I can solve this quadratic.
No.
Luckily, when I move a 16x over, it cancels with one of my 16x's. And let me subtract 112. So now I end up with 4x squared plus 16x. And what is 64 minus 112?
176 or negative 176.
Negative
No.
what?
Oh, it's positive.
Negative 48, thank you.
Come on, Ethan.
Negative 48 equals 0. Actually, let me clean that up.
Graphic.
Yes. Oops. Whoa, too much. Negative
I hate
48
this so
equals
much.
0. Yep, let's graph it. Here's my
You have
graph.
to see if your work is right.
What is my solution? Negative
Negative
6
6.
and 2.
It's negative 6.
Negative 6 and 2.
It's not that.
So who got this far? Oh, very nice. Now let's check our work. Negative 6, plug that in here, gives me a positive 6 plus 3 is 9, square root of 9 is 3. On this side, negative 6 plus 7 is 1, square root of 1 is 1, 1 plus 2 is 3. Hey, negative 6 works. Let's try 2.
No.
3 minus 2 is 1, square root of 1 is 1. Here, 7 plus 2 is 9, square root of 9 is 3, 3 plus 2 is, 2 failed, didn't it? 2 is the extraneous solution. Which means the only solution here was x equals negative 6.
I got that in my head.